Hello, this is Cardinal. Today's topic is Cardinal Utility Approach. The theory of demand or theory of consumer behavior explains the relationship between the demand for a good or service and the factors determining it. The demand of an individual for a good depends upon its price, prices of related goods, change in income, taste or preferences, etc. The law of demand states that all other things remaining same, there is inverse relationship between price and quantity demanded. Thus, the law of demand implies a downward sloping demand curve. The law of demand states that all other things remaining same, there is inverse relationship between price and quantity demanded. Thus, the law of demand implies a downward sloping demand curve. The law of demand can be explained with the help of a demand schedule and demand curve as presented in diagram 1. The demand schedule states that when the price of a good is rupees 12 per unit, the consumer purchases 10 units of it. When the price decreases to rupees 10, he would buy 20 units and so on. At rupees 2 per unit, the consumer will buy 60 units of the good. The demand schedule, when presented graphically by plotting different combinations of quantity demanded in relation to its price, would show a demand curve. The above demand schedule and demand curve states that there is an inverse relationship between price of a good and the demand for it. Now a question arises, why does a demand curve slopes downwards? The law of demand states that a fall in price of a good leads to an increase in its demand and vice versa. While increase in consumers, there is another reason for the fall in the market demand curve for a good, that is, with the decrease in price, the good becomes cheaper, which induces many low income consumers to enter into the market to buy the good. Let's discuss utility theory. Utility means the want satisfying power of a commodity. Utility is subjective entity and resides in the minds of consumers. Cardinal approach to utility states that the goods and services that provide higher levels of satisfaction will be assigned higher utils, while the goods that provide lower level of satisfaction will be assigned lower utils. Let us discuss assumptions of Cardinal utility approach. The principle of cardinal utility is based on these assumptions. First is, cardinal utility approach assumes that the utilities of commodities are numerically measurable. Second, marginal utility of money is constant. This is necessary because money is used to measure utility of a commodity. Third is, utility derived from one commodity is independent from the utility derived from another commodity. Fourth is, the marginal utility of a commodity diminishes as the person consumes more and more quantities of it. Fifth is, utility measurable by introspection. Now, what do you mean by total utility and marginal utility? Total utility refers to total satisfaction, which a consumer derives from the consumption of all the units of a good or service that he purchases at a given price during a particular period of time. When total utility, that is TU, increases, the level of satisfaction of the consumer will also rise, while marginal utility theory examines the increase in the level of satisfaction that a consumer gains from consuming an extra unit of good or service. When the marginal utility of a good is positive, it will lead to an increase in total utility. On the other hand, when marginal utility from the consumption of a good or service becomes negative, then total utility will decrease. The total utility function TU in quadratic form and is written as TU is equals to AQ minus BQ square, MU is equals to DTU by DQ, which is equals to A minus 2BQ. Slope of MU is equals to DMU by DQ, which is equals to minus 2B, that is, we are differentiating here. By taking the successive values of Q, the relationship between MU and TU is presented in table number 2. Let us see the table of total utility and marginal utility. In this table, TU is calculated by adding the successive marginal utilities of all the quantities of the good consumed. In other words, we can say TUN is equals to U1 plus U2 and so on up to UN. The relationship between TU and MU can easily be explained with the help of table and diagram. The diagram shows that when a person consumes first unit of the good, the consumer gets higher level of satisfaction. In the beginning, the total utility and marginal utility are equal at 10 utils. When he consumes second unit, the marginal utility decreases to 8 utils and the total utility reaches the level of 18 utils. Similarly, when he consumes sixth unit of the commodity, MU becomes 0 and TU reaches the maximum level, which is 30 units. Thereafter, when he consumes seventh unit of the commodity, the MU becomes negative, that is minus 2, due to which the TU declines from 30 to 28 utils. The diagram shows that the MU curve has negative slope while the TC curve has positive negative slope. Positive negative slope takes place when initially TU curves moves upwards, but subsequently it has a tendency to move downwards. With the consumption of sixth unit, MU becomes 0. When MU becomes 0, the MU curve touches the x-axis and TU curve reaches its maximum level of 30 units, which is the saturation point. Thereafter, the consumption of seventh unit will be negative MU, due to which the MU curve moves below the x-axis, which causes negative slope in TU curve. Let us discuss the relationship between total utility and marginal utility. Relationship between total utility and marginal utility can be established in some points like: first is MU is the rate of change in TU. When the MU increases, then TU increases at an increasing rate, but when MU decreases, TU increases at decreasing rate. When MU becomes 0, then TU is maximum and achieves a saturation point. When MU becomes negative, then TU declines. Moving further to laws of cardinal marginal utility analysis. The law of cardinal marginal utility states that marginal utility of a good falls as more units of it are consumed. With the above basic feature, the advocates of cardinal utility analysis have developed two laws which occupy an important place in the theory of demand. They are the law of diminishing marginal utility and the law of equimarginal utility. These two laws will be discussed in the subsequent sections. Law of diminishing marginal utility. According to the law of diminishing marginal utility, the marginal utility of a good falls as an individual consumes more units of it. Marshall, who advocated the cardinal utility analysis, stated the law of diminishing marginal utility as the additional benefit which a person derives from a given increase of his stock of a thing diminishes with every increase in the stock that he already has. In short, the law of diminishing marginal utility states that total utility increases at a decreasing rate. A rational consumer will continue to consume a good or service so long its marginal utility remains positive. However, if the consumer still continues to consume additional units of a good, then the MU becomes 0 and subsequently negative. Now, let us discuss the principle of equimarginal utility. The law of equimarginal utility is an extension to the law of diminishing marginal utility. In the words of Marshall, if a person has a thing which can be put to several uses, he will distribute it among these uses in such a way that it has the same marginal utility in all. The law of equimarginal utility is based on the fact that human wants are unlimited, whereas the resources to satisfy these wants are limited. Therefore, it becomes necessary for a rational consumer to identify the most urgent wants that can be satisfied with the limited money that he has. In order to achieve maximum satisfaction out of the limited money, a consumer is expected to carefully weigh the quantum of satisfaction obtained from each rupee that he spends. Therefore, when he feels that a rupee spent on one good gives him more satisfaction than another good, then he will decide to spend more money on the former, that is the first good. This will go on till the quantum of satisfaction that he derived from the last rupee spent on the two goods is equal. This happens when he substitutes some units of a good of greater utility for the purchase of certain units of another good which yield less utility. Because of this substitution, the mu of the former good will fall while mu of the later good will rise. This will continue until the MUs, that is marginal utilities, of both the goods are equalized. Due to this reason, the law of equimarginal utility is also called as laws of substitution. Let's see the explanation of law of equimarginal utility. According to law of equimarginal utility, a consumer will be in equilibrium at that point where the utility derived from the last rupee spent on each good is equal. Suppose a consumer has a budget of rupees 50 to buy two goods X and Y. Also suppose that the marginal utility of money, that is MUM, is constant such that rupee 1 gives 5 utils of MU. A rational consumer will spend his given budget on both the goods X and Y in such a way so that he achieves maximum satisfaction or total utility. Therefore, he will select that combination of goods at which the MU per rupee spent on each good is equals to marginal utility of money, that is MUM. Symbolically, the consumer will be in equilibrium when MUX divided by PX is equals to MUY divided by PY, which is equals to MUM, where MUX is marginal utility of good X, MUY is marginal utility of good Y, PX is price of good X, PY is price of good Y, MUM is marginal utility of money. Thus, MUX divided by PX and MUY divided by PY would give the marginal utilities money expenditure on goods X and Y respectively. The law of equimarginal utility can be explained with the help of this table and diagram. Let's see the table of marginal utility of goods purchased and marginal utility of expenditure. This table shows how a rational consumer takes decisions about purchases of different quantities of both the goods X and Y. Assume that consumer spends all his budget of rupees 50 to purchase good X. Since the price of unit of good X is rupees 5, he can buy 10 units of X. This table shows the decline in MU derived from the purchase of each subsequent unit of good X due to the application of law of diminishing marginal utility. Alternatively, assume that a consumer spends all his budget of rupees 50 to purchase good Y. Since the price of unit of good Y is rupees 4, he can buy only 12 units of Y. In this case also, MU derived from the purchase of each subsequent unit of good Y declines due to the application of law of diminishing marginal utility. Now, a rational consumer plans to allocate his budget of rupees 50 between both the goods X and Y. Since the first unit of good X gives him highest utility, that is 50 utils, his first purchase would be X, which he buys at a given price of rupees 5 per unit. The purchase of second and third units of X will also provide relatively higher utility for good X. Thus, his first choice will be to buy 3 units of good X. Since the fourth unit of X provides lower MU, that is 35 utils, than the first unit of good Y, that is 36 utils, the consumer will buy 1 unit of good Y at rupees 4. Let us see the diagram. The x-axis measures the units of goods X and Y measures the MU of money spent on X and Y. The consumer will achieve maximum level of satisfaction when he decides to buy 6 units of X and 5 units of Y. And at that level, the MU of money spent on each commodity is 5 utils. Thus, it can be concluded that a rational consumer would obtain maximum satisfaction when he equalizes the marginal utilities of goods that he purchases by substituting some units of one good for another. Now, let us see the table of marginal and total utility of goods purchased. This table shows the subsequence of goods X and Y purchased by the consumer. He decided to buy X as his first, second, third, fifth, seventh and ninth choice. And he decided to buy Y as his fourth, sixth, eighth, 10th and 11th choice. It may be noted that for his 11th choice, both the goods X and Y provided him same level of satisfaction, that is 20 utils of MU. In such a situation, the consumer has to use his own option and buy that choice in more economical. In the present case, at the 11th choice, the consumer is left with only rupees 4 as he already spent rupees 46 to buy earlier 10 choices. Therefore, he buys good Y and pays rupees 4 for his 11th choice. This way, he purchases 6 units of good X and 5 units of good Y and spends all the amount of his budget, that is rupees 50. Decision to buy based on MUs of both X and Y will provide maximum satisfaction. Thus, total utility of 6 units of X would be 225. We are calculating 50 plus 45 plus 40 plus 35 plus 30 plus 25, which is 225 utils. And 5 units of Y would provide 140 utils, that is 36 plus 32 plus 28 plus 24 plus 20, which is 140. Thus, total utility of all his purchases will give 365 utils. The satisfaction given by 6 units of X and 5 units of Y at different prices would be greater than any other combination. At this combination of transaction, he will equate his marginal utilities from the goods and money budget. Moving further to derivation of demand curve. The consumer demand curve generally slopes downwards due to decrease in marginal utility that a consumer derives by consuming more of a good or service. Demand curve also has a negative slope because a consumer wants to obtain as much as satisfaction as possible at the lowest possible price. Therefore, when prices decrease, consumers increase their purchases of that product and vice versa. With these basic premises, the founders of cardinal utility analysis have developed two laws, namely law of diminishing marginal utility and law of equimarginal utility. These two laws occupy an important place in economic theory and have several applications and uses. With the help of these two laws, the exponents of cardinal utility analysis have derived the law of demand. Let us discuss derivation of demand curve under the law of diminishing marginal utility. The law of diminishing marginal utility states that so long as the marginal utility of a good is higher than its price, that is MUX is greater than PX, the consumer would demand more and more units of it till its marginal utility is equals to its price. Thus, the marginal utility equals price is the precondition of equilibrium. Let us see in the diagram. In this diagram, the downward sloping curve represents the diminishing marginal utility of the goods measured in terms of money, price is measured on y-axis and quantity purchased is measured on x-axis. Suppose a new product X is introduced in the market at OP1 price. At this price, the consumer will be in equilibrium when buys only 1 unit of it because the MU of product is MU1, which is equals to the given price OP1. Now, if the price falls to OP2, the equality between MU and the price will be disturbed. Marginal utility of money expenditure MU1 at quantity Q1 will be greater than the new price OP2. In order to equate the MU with the new price, the consumer will buy one more unit of X. It is evident from the diagram that when the consumer increases the quantity purchased to Q2 units X, the marginal utility of money expenditure on X falls to MU2, which is equals to the new price OP2. Likewise, when prices fall further, the consumer will buy more units of X in order to equate its marginal utility of money expenditure to the lower price. In this way, the downward sloping MU curve is transformed into a downward sloping demand curve. Now, let us discuss derivation of demand curve under the law of equimarginal utility. As discussed earlier, consumer equilibrium is attained when a consumer, while purchasing different goods, decides to select that combination of them at which the MU per rupee spent on each good is equals to MU of the money, which is MUM. Symbolically, in case of two goods X and Y, the consumer will be in equilibrium when MUX divided by PX is equals to MUY divided by PY, which is equals to MUM. In order to understand the derivation of demand curve under the law of equimarginal utility, let us see in the diagram the demand for good X only. In the upper portion of the diagram, the y-axis represents the MU of money expenditure, that is MUX by PX, while the x-axis represents the quantity of good X demanded. With a given level of income, the budget of the consumer is fixed and his marginal utility of money is equals to OH. The consumer buys OQ1 quantity of good X when the price is PX1 because at this price the MU of the money OH is equals to MUX divided by PX1 and a point R on their intersection that measures the MU of money expenditure for OQ1 quantity of X. At the bottom of this diagram, the demand curve for good X is derived. In this part of the diagram, the price is measured on y-axis and quantity demanded on x-axis. When the price of a good X is PX1, it corresponds with the relevant MUX divided by PX1 curve, which is the MU of money expenditure on good X. Thus, the consumer would demand OQ1 quantity of good X at price PX1. Point A, marked at the intersection of two perpendicular lines drawn through RQ1 and PX1, would be the first decisive mark for the derivation of a demand curve. When price of X falls to PX2, the MUX divided by PX2 curve representing MU of money expenditure shifts upward to the new position. The consumer would buy OQ2 quantity of good X because at price PX2, MU of money OH is equals to MUX divided by PX2. Point S on their intersection measures MU of money expenditure for quantity OQ2 of X. In the lower part of the diagram, a point B is marked at the intersection of the two perpendicular lines drawn through SQ2 and PX2, which is the second decisive mark for the derivation of the demand curve. Similarly, when the price of X falls to PX3, the MUX divided by PX3 curve representing to MU of money expenditure shifts upward to a new position. The consumer would buy OQ3 quantity of good X because at this price the MU of money OH is equals to MUX divided by PX3. Point T on their intersection measures the MU of money expenditure for quantity OQ3. Point C marked at the intersection of two perpendicular lines drawn through TQ3 and PX3 would be the third decisive mark to derive demand curve. Similarly, if the price of good X change further, it will be possible to find the quantity demanded at the new prices. Thus, by drawing a line through these points, that is A, B and C, demand curve DD for good X is derived. The demand curve DD slopes downwards, which states that every fall in price of a good, the demand for it will increase. Let's conclude the session. Today, we have discussed cardinal utility approach of consumer demand, derivation